Hey everybody, today's focus is going to be star brightness, and if you did what you were supposed to have done, you would have learned in the last several slides that star size is the primary factor that determines star temperature, and star temperature then influences star color. Star brightness is a bit different though, because we have to consider the vast distances in space um, as to how an object appears here on Earth versus what it might look like if you're right in front of it out in space. So I would recommend you know the differences among luminosity, apparent magnitude, and absolute magnitude, although our focus here again is going to be apparent magnitude. We'll come back to absolute magnitude when we do an HR diagram, which will be our next activity following the apparent magnitude assignment on the next slide. So what we need to do is take a look at what information is presented. So we have here object apparent magnitude, Jupiter versus Vega, and apparent magnitude of full moon versus El Nair. We look at this chart information down here, the difference in apparent magnitude, which will calculate based on how it would appear on a number line, and then how that difference in apparent magnitude determines the amount of light output differences among the different objects, again, from our view on Earth. So if we look at Jupiter, Jupiter has a -2. And if I want to go to 0, I have to take 2 full steps to get 0 from -2. So the difference is 2. And 2 equals a 6.3 times as amount of light output from Jupiter as compared to Vega from our view on Earth. So just to write that out, 6.3 times as bright. And then we will do the same thing with a full moon versus El Nair. Now, the full moon, as is quite obvious, is very, very bright. It's reflected light, but at nighttime, it's so much brighter to us based on how close it is compared to any other star. Although knowing how bright our own star is, the sun, which again is much larger than the moon, and even though it's much farther away, it still appears very, very bright as compared to the other stars in the night sky, which are even farther away. So the full moon has a -12.5. So again, if I go to my number line, I have -12.5, and I have to go all the way down to 0, which is 12.5 steps. And then I need to go up to El Nair, which is 1.73. So 12.5 plus one more step is 13.5. And 2 more steps would be 14.5, but we don't go quite 2 steps, so I'd back off a little bit. And it'd actually be 14.23 steps on the number line if it was incremented out to that accuracy. So 14.23 for our purposes is roughly 15 as a difference in apparent magnitude, and that equate to 1 million times the amount of light output from the moon as compared to El Nair. So just to be consistent here, I'm going to write that in, and then you'll do the same thing solving a variety of problems on the assignment sheet, which you can link to from the next slide. So 1 million times as bright. Hopefully this helps you work through the problems on the next page. If not, please reach out. Thanks.